Okay, in the previous video we have seen, we were seeing the type of the work done, that is positive work done, negative work done and zero work done. We have seen that we get the zero work done in two cases. Like first case we have seen that when the angle between the force and displacement is 90 degree, then we get cos theta, that is cos 90, which is 0, so we get the work done 0. Also, in the second condition, when there is no displacement in the body, then also the work done is 0, isn't it? Like if you are having a wall and you are applying the force on the wall, so you are giving some magnitude of force, but then there is no displacement. So this thing you have learned in class 8 already, that F into D. So here F, you are applying some amount of force, but then the displacement is 0, that is overall work done is 0. So work done is 0 in two cases, when the angle between force and displacement is either 90 or the displacement in the body is 0. There is no displacement, there will be no work done. Okay, so this is the case when we are talking about the 0 work done. Also, we have seen in the first video beta, we have seen the units of work done. So we are gonna see a little more about the unit of work done. We have seen as work done is force into displacement. Here I'm not writing cos theta. Cos theta, that is cos, if you write cos theta, and when I'm not writing cos theta, that means I'm taking theta as 0 degree. Like if you see theta 0 degree, what it will become? W is equals to F D cos 0 degree. 0 degree means that the force and displacement, they are in the same direction, then only the theta is 0. So that is W is equals to F D. Cos 0 is 1, so it is simply F into D. So work done is FD. So when I write FD only, that means I am taking the force and displacement in the same direction. So here we are having this thing, FD, W is equals to F into D. Now the unit of work done, as we have seen, force is in Newton, the SI unit, and displacement is meter. Also it is called joule. This is what we have seen. This is the SI unit. We are going to see the relation between SI unit and CGS system. Okay. So here we have 1 Newton meter. So we are going to convert Newton into dyne. We know that the Newton is an SI unit and dyne is in CGS system. So dyne and meter we are going to change into centimeter. We already have learned that 1 Newton is equals to 10 to the power 5 dyne. How it comes, I think you all know that Newton is a unit of force. Force is mass into acceleration. Then you can change and you can proceed. If don't know, you can search a little, otherwise you can ask. If you're not getting this, you can ask. Okay, and then we have 1 meter. What is the smaller unit? That is centimeter. So 1 meter is 10 to the power 2, that is 100 centimeter, or 10 to the power 2 centimeter. So overall it is 1 Newton meter will be 10 to the power 5 dyne, and meter is 10 to the power 2 centimeter. So overall it is 10 to the power 7 dyne centimeter. So 1 Newton meter is equals to 10 to the power 7 dyne centimeter. 1 Newton meter is also known as 1 joule. So it is 10 to the power 7, and dyne centimeter is arc, smaller unit. So 1 joule is equals to 10 to the power 7 arc. It is also given in your book. You can see to solve the numericals and all. Okay. Okay. Now the next topic is work done by the force of gravity. Okay, so first let us understand what is the idea, or what is the heading now. we are going to see the work done. We know work done is force and displacement. How we calculate work done? Force and displacement. So work done by which type of force? We are talking about the force of gravity, that is Earth's gravitational pull. So we are going to take the Earth's gravitational pull, and because of that, if there is any displacement in the body, then force into displacement will give us the work done, and that's what we are going to do. So how are we going to calculate? Simple formula, force into displacement. We calculate the force, we calculate the displacement, and we see. Okay. Now if you see an example beta, if you are moving on an inclined plane, I have told you what is an inclined plane. Like if it is a horizontal plane and this is this plane is known as inclined plane at an angle theta. So if it is an angle theta. So like you can take it example as you are moving on a hill, you are moving on a slope, you are moving in fact on a staircase. Staircase is like that, no? So at an angle theta with the horizontal staircase. These are the examples of an inclined plane. So when you are moving up beta, what is the force acting on a body or on you or whosoever is moving up? That is the force of gravity which is acting vertically downward, isn't it? Your weight acting vertically downward, isn't it? So that is the force acting on the body, weight or force acting on the body. And what is the, see, what is the vertical displacement? We have learned that the displacement is the shortest distance. So what is the vertical displacement? उसका height कितना होगा? इतना ही तो होगा. Horizontal say what is the height? This is the height of the body. No, if you are moving on a staircase, what is the vertical displacement? That is the height attained by the body. Not this distance, but the height attained by the body. And that should be the displacement. It must be the shortest. So the work done is force into displacement. Is it clear? Okay. So work done is equals to force. What force is acting on the body? That is equal to the weight of the body. F is equals to mg into what is the displacement? The vertical displacement, that is h. So it is simply mgh. What amount of work done is there in the body? That is mgh. Okay, now here is some point. Here are some points which you are gonna see. First is work done mgh. That means, and I think you all can remember that mgh we have learned, it is the expression of the potential energy, mgh. Now can you please slightly recall the potential energy? Potential energy of a body is because of the position or state of the body or configuration of the body. So potential, body is here, this is the position of the body at a height h. So what is the energy stored in a body? Will be mgh, and we know that work and energy, work is a form of energy. So it is how mgh, which we are going to see further. I'm just telling you if you can relate. Also here if we talk about the direction, if the body is moving in the upward direction, like if you are taking the body on the staircase and you are moving up, so that means the weight is acting downward but the displacement, weight is downward but the displacement is in the upward direction. So weight downward, displacement upward. What is the angle between force and displacement here? It is 180 degree. So what will be the work done? As we have learned that the work done, if the work done and force they are in the opposite directions, the work done will always be negative because it is F into D into cos theta. Theta is 180. 180 will be minus 1. So it will be minus mgh if the body is moving in the upward direction. If the body is moving in the downward direction, the gravity is acting in the downward direction. The displacement is also in the downward direction. Gravity, downward direction. That is the weight. Also the body is coming down. That means the displacement is also in the same direction. Both of them are in the same direction. What is the angle? 0 degree. So that means the work done will be simply mg, which is force into displacement, that is h. You can show it by h or you can show it by d. So that is the work done by the force of gravity. mgh when the body is coming down, minus mgh when the body is moving against the force of gravitation. I hope it is clear for you all, and if you have any problem or anything which is not clear to you, you can ask in the comment section. Okay, so here this is all about the work done. We have learned, I think I have in the first video I have already revised what we have learned. We have learned the definition, we have seen the unit, we have seen the mathematical expression, and what is the angle. Okay. Okay, so we have seen work. Before we start, we go to our next topic part. Let's see one numerical based on that. It is given in your book, numericals, and I think this is the first one. I'm gonna read, and I have already written the information given. So here, a body when acted upon by a force of 10 kgf. Here, force is given 10 kgf. Then gets displaced by 0.5 meter. Displacement is 0.5 meter. Calculate the work done. You have to calculate the work done by the force when displacement is. Three conditions are given. That is, displacement is in the direction of force. The first condition is displacement is in the direction of force. We know when displacement and force, they are in the same direction, beta. What is the angle between them? That is cos. That is theta should be 0 degree. Acha. Before we go here, if you see beta, it is 10 kgf given, and the unit of work done is Newton meter. So I think it would be better if we convert this 1 kgf into Newton. How to do it? That is, we have to multiply it by 10. So 10 into 10 will become 100 Newton. I think you all know the relation between Newton and kgf. If not, you can recall your previous chapters which you have learned. These are your things. Okay. Now here we have W is equals to F D cos theta. This is our formula what we use. That is, F is, now we will put this value 100. Unit, you need to be very careful. Sorry, as I have written Newton, it should be Newton only. 100 into what is displacement we have? That is 0.5. And cos theta, since displacement and force is in the same direction, theta will be 0 degree. That is cos 0 degree. So that is cos 0 is 1. So it is 100 into 0.5 into 1, and that would be 50 joule. You can write it Newton meter also. You can write joule, as we know that 1 Newton meter is 1 joule. Okay, so this is the first part. Now the second part is when the force and displacement are in the same direction. Second, when the force and the displacement are at an angle of 60 degree. Means that the angle between them is 60 degree. So if you see beta, that the force and the displacement, the angle between them is 60 degree. That means theta is given 60 degree. Again we will do the same thing. W is equals to F D cos theta. F we have calculated, that is 100 Newton. Displacement 0.5. Cos theta, theta is 60, that is cos 60 degree. That is 100 into 0.5 into cos 60. We all know cos 60 is 1 by 2. This will be 50 into 1 by 2, and that it will be 51 by 2, that is 25 joule, or you can write Newton meter. Now the third part is when the work done by the force, when the displacement is normal to the force. Now we know normal to the force or perpendicular to the force, that means the angle between both of them must be 90, and this is so quite obvious. When the angle is 90 degree, we have learned the work done will always be 0, as cos 90 will always give you 0. This is the condition we have learned, that the 0 work done can be because when the angle is 90 degree, that is the force and the displacement are in the perpendicular direction, or there is no displacement. So these type of numericals are given. You see other numericals. If there is any problem, you can ask, and I'll be there to help you all. Okay. So this is how we see work done, and this is how we calculate work done.